Descriptive Statistics. In today's video, we'll cover frequency distribution. The objectives are know how to construct a frequency distribution including limits, midpoints, relative frequencies, and cumulative frequencies.
Frequency distribution is a table that shows classes or intervals of data with a count of the number of entries in each class.
Here's a frequency distribution with classes and their frequencies. Under the class, the first column is the lower class limit LCL, which tells us the smallest value that can be included in a class interval. The second column is the upper class limit UCL, which tells us the highest value that can be included in a class interval. Class width is the difference between the UCL and LCL of a class interval. Let's work through this example together. The following sample data set lists the prices in dollars of 30 portable global positioning system navigators. Construct a frequency distribution with 7 classes. The important things to note here are the 30, which represents the sample size, and the 7, representing the number of classes. Now let's rearrange these numbers from smallest to largest. Here are the few steps to follow when constructing a frequency distribution. Step 1. Identify the number of classes. Step 2. Find the class width. Step 3. You can use the minimum data entry as the lower limit of the first class. Then find the remaining lower limits by adding the class width to the lower limits of the preceding class. Then find the remaining upper class limits. Step 4. Make a tally mark for each data entry in the row of the appropriate class. Step 5. Count the tally marks to find the total frequency for each class. Let's continue with our question. First, we identify the number of classes, which is given as 7. Secondly, we have to find the class width using the formula maximum minus minimum value / number of classes. As you can see, our maximum value is 450 and our minimum value is 59. So we subtract the minimum from the maximum and divide by 7. That's how we got 56 as the answer. Step 3, we'll use 59, the minimum value, as the first lower limit. After that, we'll add the class width, which is 56, to get the lower limit of the next class. We add the class width to the first lower class limit to get 115. Find the remaining lower limits. The upper limit of the first class is 1 less than the lower limit of the second class. Then add the class width. Find the remaining upper limits. Step 3. Make a tally mark for each data entry. As you can see, the values that falls within the class interval 59 to 114 are 5. FR 115 to 170. There are 8 values. From 171 to 226, there are how many? 6 values. As you can see, this is simple. From 227 to 282, there are 5 of them. There are 2 values from 283 to 338. Oh, look at that. There's only one from 339 to 394. Last one is from 395 to 450, and they are 3. 5. Count the tally marks to find the total frequency for each class. Moving on to midpoint of a class. The midpoint is the middle value of a class interval. The formula is lower limit plus upper limit divide by 2. As you can see, for the first interval, we had 59 and 114, then divide by 2. We get 86.5. Do the same to the other intervals. For relative frequency of a class, the formula is class frequency divided by the sample size. Remember, the sample size is given as 30 on the statement. So we say 5 divides by 30 to get 0, 17. Then do the same to the rest. Our last objective, the cumulative frequency of a class. Cumulative frequency is the running total of frequencies. It's the sum of the frequencies up to a certain point in the data. The first one will be the same as the first frequency. Then add the next frequency to the previous cumulative frequency, meaning we add 8 to 5 to get 13. And so on until the last one,